Welcome to the Sleepy Brain Dose. Tonight, we'll drift together into the calm science of rain. Soft droplets, quiet clouds, the gentle rhythm of water returning to the earth. No rush, just simple truths told slowly to ease your mind and carry you toward rest. So settle in, breathe deeply, and let the sound of science become a soft background for sleep. Rain is one of the most ordinary experiences in our daily lives, and at the same time, one of the most profound. You have felt it on your skin, you have heard it against windows, and you have watched it soften the outlines of the world outside. But what exactly is rain? When we pause, slow down, and let the question settle, we begin to see that even something so common is full of quiet wonders. At its essence, rain is simply water that falls from the sky. That description sounds almost too simple, yet it contains layers that are worth unfolding. The water that becomes rain is not new. It is part of a cycle that has been flowing on Earth for billions of years. Every droplet that lands on your hand has been in the oceans, in the rivers, in the air, and perhaps in the cells of living beings. When it falls as rain, it is only one stage of a long journey. To begin to understand rain, it helps to start with the air around us. Even when the sky looks perfectly clear, the air always contains water. This water is invisible because it is in the form of vapor. You breathe it in and out without noticing. You can think of the air as holding a gentle, hidden reservoir of moisture. When conditions are right, that hidden moisture changes state from vapor to tiny droplets. And those droplets are what eventually gather together into the falling water we call rain. When we use the word rain, we are naming the moment when these droplets, formed high above, grow large enough and heavy enough to be pulled downward by gravity. It may seem simple. A cloud releases water, and the water falls. But in truth, the process is slow, patient, and full of small steps. Each raindrop is not just a single unit of water, but a gathering of countless molecules, bound together by the subtle forces of nature. Another way to see rain is as the Earth's natural delivery system for fresh water. The oceans hold almost all of our planet's water, but they are salty, and that salt cannot sustain most life on land. Through the process of evaporation and condensation, the Earth lifts fresh water from the oceans, carries it across the sky, and gently returns it to the ground in the form of rain. In this way, rain is not just an event in the weather. It is a part of life's foundation. Every plant, every stream, and every living being depends on it in some way. From a physical perspective, a raindrop is a collection of liquid water molecules held together by surface tension. At first, these drops are microscopic, far too small to see. They drift and float inside clouds, suspended by the rising currents of air. Only when they collide with one another and merge do they start to grow. When they have reached a size where the upward currents can no longer hold them, gravity begins to draw them downward. The fall is slow at first, because air resists their motion. But as the drop gathers momentum, it takes on the familiar shape of the falling rain you recognize from looking out the window. If you have ever wondered why raindrops are not shaped like perfect teardrops, the answer is gentle and simple: small. Droplets are nearly spherical because the molecules of water cling to each other in balance. As the drop falls, the air pushes against its underside, flattening it slightly. In the largest drops, the bottom may curve inward, creating a shape more like a hamburger bun than a teardrop. The familiar drawing of the pointed raindrop is more a symbol than a physical reality. In truth, rain is rounder, softer, less dramatic. Rain also connects us to time on a much larger scale. The droplets falling today may once have been part of an ancient ocean millions of years ago. The same water that nourished early forests, that filled prehistoric lakes, is the water that you feel on your skin. Nothing is lost, only recycled. This continuity is part of what makes rain feel grounding and eternal. The cycle goes on quietly, beyond human lifetimes, beyond civilization's dot to the senses. Rain can be experienced in many ways. You might notice the coolness on your skin, or the soft rhythm it makes as it lands. You may sense the shift in the air as the world grows damp and refreshed. These experiences are more than just surface impressions. They are gentle reminders of the bond between the atmosphere and the ground beneath your feet. Rain is how the sky touches the earth, how the invisible becomes visible, how the hidden vapor is revealed. And yet, despite its familiarity, rain is never quite the same twice. A drizzle feels different from a downpour. A summer shower carries a different warmth from an autumn storm. Each rainfall is shaped by countless variables: the temperature of the air, the currents of wind, the size of the droplets, the landscape onto which they fall. To notice these subtle differences is to realize that rain is not a single thing, but a family of expressions dotted in cultural history. Rain has also been a quiet constant. Farmers have waited for it. Poets have written about it, and entire communities have celebrated its arrival. It has been seen as blessing, as renewal, as cleansing, and sometimes as sorrow. No matter the interpretation, the presence of rain has always been significant. That is because, at a very basic level, we depend on it for survival. The food we eat, the rivers we draw from, the forests we walk through, all are nourished by rain. At the same time, rain is also deeply personal. The sound of rain at night can bring comfort, a reminder of safety indoors. The sight of rain on a window can invite reflection, a pause in the busyness of the day. In these ways, rain is not just an environmental event, but an emotional one. It touches not only the soil and the rivers, but also the mind. To describe rain, then, is to describe both a scientific process and a human experience. It is molecules gathering in the sky, and it is also the feeling of calm when you hear it falling in the dark. It is the mechanism by which the earth refreshes itself, and it is also the quiet moment when time seems to slow. By seeing it in both ways, you can appreciate how ordinary and extraordinary rain truly is. When you think of rain in this calm, unhurried way, you may notice a sense of rhythm. Just as the droplets gather, grow, and fall, so does the narrative of life move in cycles. Rain is only one expression of this deeper rhythm. To watch it, or to listen to it, is to be reminded of the larger patterns at work, patterns that connect you to the earth, to history, and to the flow of time itself. So, when you next hear the gentle patter of rain, you may remember that what you are witnessing is both simple and profound. It is water returning to the earth. It is the atmosphere finding balance. It is the world refreshing itself. And within that simplicity, there is an entire story of physics, chemistry, and life, playing out quietly in the background. Rain, then, is not just weather. It is the quiet heartbeat of the planet. When we think about rain, we often imagine the visible part, the droplets that fall from the sky, the clouds that gather above, the sound of water touching the earth. Yet, long before rain appears, there is another, more hidden stage. That stage is water vapor in the air. Understanding this invisible presence is like lifting a veil. It shows us that the sky is never empty, never completely dry. Even when the day seems clear, the atmosphere is carrying water, silently, patiently, waiting for the right conditions to reveal itself. Water vapor is water in its gaseous form. Unlike liquid droplets, it cannot be seen with the eyes. If you look up at a blue sky and see nothing but color, the truth is that countless molecules of water are floating there, moving freely, mixed with the nitrogen and oxygen that make up most of the air. You do not sense them directly. They do not cast shadows or form shapes, but they are always present. This invisible vapor is part of why the earth feels alive and balanced. Without it, our skies would be barren, our lands dry, and the cycle of water that sustains plants, animals, and people would be broken. In a quiet way, water vapor is the first step in every rainfall, the silent beginning of every stream and river dot. To picture how it works, imagine the surface of the ocean. Under the warmth of the sun, some molecules of water gain enough energy to break free from the liquid below. They slip into the air, rising as vapor. This is evaporation, and it is happening constantly across oceans, lakes, rivers, and even the dampness of soil and leaves. You do not see the vapor leaving, but if you stand near a hot surface after rain, you may sense a shimmer in the air. That shimmer is a hint of vapor becoming visible. As light bends through the rising moisture dot, the same process happens when you boil a kettle of water. You notice steam rising, but what you actually see are not the molecules of vapor themselves. The white mist above the kettle is made of tiny droplets that form when the vapor cools quickly. Pure vapor, in its true gaseous state, is invisible. This distinction is subtle, but important. It reminds us that the atmosphere holds far more water than our eyes can ever confirm. The amount of vapor in the air is not fixed. It depends on temperature, on pressure, on the availability of water at the surface. Warm air can hold more vapor than cold air. That is why summer often feels humid, heavy with moisture, while winter air can feel dry and crisp. This capacity of the air to hold vapor is measured as humidity, and it is a gentle but powerful influence on how comfortable we feel. When humidity is high, the air is close to saturation. This means the invisible reservoir of vapor is nearly full. A small cooling or a small disturbance is enough to trigger condensation, the step when vapor becomes visible droplets. When humidity is low, the reservoir is far from full, and vapor has room to remain suspended. These variations shape not only how our skin senses the air, but also how likely rain is to form. You might notice how humidity affects your own experience of breathing. On a very humid day, each breath can feel thick because the air is carrying so much hidden moisture. On a dry day, your skin and lips may feel parched because moisture is leaving your body more quickly into the thirsty air. In both cases, what you are really sensing is the presence, or the relative absence, of vapor. Water vapor is also a carrier of energy. Each time a molecule of water evaporates, it absorbs heat from its surroundings. This heat is stored invisibly, carried into the atmosphere along with the vapor itself. When the vapor later condenses back into liquid, the stored heat is released. This exchange, known as latent heat, is one of the engines of weather. It drives the rising of air, the formation of clouds, and the eventual falling of rain. Without vapor, the atmosphere would lack this subtle but essential energy flow. Although we cannot see vapor directly, its presence reveals itself in small signs. Fog on a window, dew on the grass in the morning, or the hazy look of air on a summer afternoon. These are gentle reminders of vapor shifting state. Even your own breath on a cold day is proof. The cloud you see leaving your mouth is not the vapor itself, but the droplets that form. When that vapor meets cold air and condenses, it is worth pausing to reflect on how much water the air can carry. The atmosphere may seem light and insubstantial, But at any moment, it contains an astonishing volume of vapor. Globally, it is estimated that the atmosphere holds the equivalent of thousands of cubic kilometers of liquid water in vapor form. All of it is circulating, moving with winds, lifted by warmth, cooled by altitude. This vast store is the hidden reservoir from which clouds draw their supply. What makes vapor even more remarkable is its transience. A molecule of water may remain in the atmosphere as vapor for only a short time on average, about a week before it condenses and falls again. This means the vapor above you today may soon become a drop of rain elsewhere, or a flake of snow, or a bead of dew. The turnover is constant, renewing the link between the oceans, the land, and the sky. From a human perspective, vapor is something we rarely think about. It does not demand attention the way rain does. Yet without it, rain could never form. It is the quiet background, the subtle foundation. To understand vapor is to recognize that every rainfall begins invisibly, in molecules floating freely, waiting for their moment to gather dot in this sense. Vapor is both delicate and powerful. Delicate because it is unseen, easy to forget. Powerful because it holds the potential for rivers, for storms, for the nourishment of life. By carrying energy and moisture through the atmosphere, vapor connects distant places. The water that evaporates from the Pacific Ocean may later fall on mountains thousands of kilometers away. What seems like an invisible trace in the sky is, in fact, a global traveler dot. As you listen to this, you might imagine the calm steadiness of the cycle. Molecules rising from a warm surface, dispersing into the air, drifting quietly until they meet conditions that invite them to return. No rush, no noise, only rhythm. This rhythm is not unlike breathing an exhale of water into the air, an inhale of condensation back to the ground. The earth breathes through vapor, slowly and continuously. When you next walk outside on a summer day and feel the air thick with moisture, you might remember that this heaviness is vapor. When you see your breath in the winter cold, you might recall that it is vapor becoming briefly visible. And when you hear the first drops of rain, you may know that the process began long before, with invisible molecules leaving the surface of the earth and rising into the atmosphere. Water vapor, though unseen, is the quiet seed of rain. It is the stage before the visible, the potential before the event. By noticing it, even in thought, you can appreciate how the atmosphere is never empty, always holding, always preparing. In the calm presence of vapor, the story of rain begins. If water vapor is the hidden beginning of rain, then condensation is the moment when the invisible starts to take shape. It is the bridge between what we cannot see and what eventually becomes the droplets that fall to the ground. Condensation is a quiet, steady process, yet it is also delicate and precise. It is through condensation that rain is born, molecule by molecule, in the high and shifting air. At its most basic, condensation is the change of water from its gaseous form into liquid. A molecule of vapor moving freely among the gases of the atmosphere slows down, loses energy, and clings to others. When enough molecules gather together, they form a droplet. But in the real atmosphere, this transformation does not happen in an empty sky. It needs something to hold on to. That something is a microscopic particle, floating unseen. These particles are called cloud condensation nuclei. They may be grains of dust lifted from the ground, tiny crystals of salt carried up from the ocean, fragments of smoke, or even pollen drifting on the wind. The air is never perfectly clean, and this natural impurity is what allows condensation. To begin, a water molecule on its own may struggle to stay liquid in open air, But when it finds a solid or soluble surface, it can anchor itself. And others soon follow. In this way, every droplet in a cloud begins its life as a partnership between water molecules and a particle. Without these nuclei, a vapor could remain suspended far longer, reluctant to form visible water. With them, the transition happens quietly and efficiently. What looks to us like a single cloud is actually a vast gathering of countless tiny droplets, each one wrapped around its own nucleus. The droplets that form in this early stage are unimaginably small. Most are less than 1/100th of a millimeter in diameter. They are so light that they do not fall. Instead, they remain suspended in the air, drifting with the currents, held up by the gentle turbulence within the cloud. This is why clouds appear to float. They are made of liquid, but the droplets are too small to overcome the movement of air. To the human eye. These droplets blend together into a visible mass, giving the cloud its familiar appearance. Yet, if you could enter a cloud and look closely, you would see a mist of tiny spheres, hovering, colliding, and separating again in constant motion. The softness you see from the ground is actually a living texture of microscopic water. Condensation depends on the balance between temperature and humidity. When warm, moist air rises, it cools as it expands at higher altitudes. Cooler air cannot hold as much vapor, so the excess vapor condenses. This is why clouds so often form when air is lifted by mountains, by weather fronts, or simply by the warming of the ground and sunlight. The rising, cooling, and condensing is a cycle that repeats endlessly. Shaping skies and preparing the way for rain. It is important to realize that condensation is not just a passive result of cooling. It is also a release of energy. When vapor condenses into liquid, it gives back the hidden heat it carried when it evaporated. This release warms the surrounding air, making it lighter and encouraging it to rise even higher. That rising draws in more moist air, leading to more condensation. In this way, condensation feeds itself. Like a calm but persistent engine of the atmosphere. The growth of droplets through condensation alone is slow. A droplet may form and gradually add more molecules from the vapor around it, but this process by itself cannot quickly create the large raindrops we know. To reach the size needed to fall, droplets must also collide and merge with each other, a stage that comes later. Still, condensation is the essential first step. Without it, no droplet could exist to begin that growth. Every drop of rain that has ever touched the earth began in this manner, an invisible molecule of vapor condensing onto a microscopic speck, joining with others, and slowly building into something tangible. To think of this is to appreciate how ordinary dust or salt, carried unnoticed through the air, becomes the foundation for rivers and lakes. The grand flow of water across continents rests on events too small to see. In daily life, you can observe condensation in more familiar ways. When moisture beads on the outside of a cold glass, it is vapor condensing onto a cool surface. When a bathroom mirror fogs after a shower, the warm air has met a cooler surface, and droplets have formed. Clouds in the sky are the same process, but on a grander scale and in constant motion. Each example shows how condensation is a universal principle, repeating from the smallest to the largest scales. Condensation also explains some of the beauty of the natural world. The silver mist rising from a valley in the early morning is condensation of vapor as the air cools overnight. The shimmering halo around the moon on a damp night is caused by light scattering through droplets formed by condensation high in the earth atmosphere. Even the dew that glistens on grass at dawn is water vapor condensing directly onto blades of plants. Cooled by the night air, not by itself, condensation is not dramatic. It does not crash or roar. It is a patient, quiet process, building structure out of the invisible. Yet without it, there would be no clouds, no rain, no streams, no oceans as we know them. The world's water would remain hidden, locked as vapor, unavailable to sustain life. Condensation is the gentle threshold between potential and reality. You think of rain beginning, you might imagine dark clouds rolling in, or the first drops hitting the ground. But in truth, it begins earlier, in silence, with vapor molecules finding one another, joining around tiny particles, and deciding, so to speak, to stay together. The birth of droplets is a moment of gathering, of cohesion, of quiet assembly. There is something reassuring in this patience. The atmosphere does not rush. It allows vapor to float freely, sometimes for days, sometimes for weeks, before inviting it to condense. When the time is right, the transformation happens naturally, without force, without struggle. It is a reminder that nature's rhythms are unhurried, and that what seems sudden to us has been quietly forming for a long time. By appreciating condensation, you can see clouds in a new way. They are no longer just shapes drifting overhead. They are vast communities of droplets, each one the result of countless molecules coming together. They are the visible expression of the invisible work of condensation. And within those clouds lies the potential for rain, for nourishment, for renewal. So, the next time you look up at the sky and notice a cloud, you might remember the countless acts of condensation taking place within it. You might imagine the vapor molecules slowing down, clinging together, forming droplets too small to see. And you might recognize that this quiet process is the true beginning of rain. Condensation, though hidden from our direct sight, is the gentle moment of creation. It is how rain is born. When we look up at the sky and see a cloud, it can seem like the most ordinary sight. A soft shape, drifting above, sometimes bright and white, sometimes dark and heavy. Yet when we pause, slow down, and truly reflect, we realize that a cloud is far more than a decoration of the sky. A cloud is the home of droplets. It is the place where rain begins its visible life. To understand clouds, it helps to think of them not as solid objects, but as gatherings. A cloud is not made of cotton or misty smoke, though it may look like it. It is made of countless tiny droplets of liquid water, or sometimes tiny crystals of ice, suspended in the air. Each droplet is so small, so light, that rising air can hold it aloft. Together, billions of these droplets create the visible form we call a cloud. From the ground, the edges of a cloud appear smooth, but in reality, they are dynamic and full of motion. Air currents within the cloud are constantly rising, falling, swirling. Droplets are forming, colliding, evaporating, and reforming. The cloud is alive in a gentle rhythm, a balance of creation and dispersal. What looks like stillness is actually a dance of molecules, too small and too slow for us to notice directly. The way a cloud forms is patient and natural. Warm, moist air rises from the surface of the earth. As it rises, it expands and cools. Cooler air cannot hold as much water vapor as warm air, and so, at a certain height, the vapor begins to condense. Tiny droplets form around microscopic particles, and when enough of these droplets gather, the mass becomes visible as a cloud. It is not a single thing created all at once, but rather a gradual thickening, a quiet layering of countless small events. Different conditions create different kinds of clouds. Thin, wispy cirrus clouds stretch high in the sky, formed of ice crystals where the air is cold. Puffy cumulus clouds float lower, looking like soft heaps of white. Layered stratus clouds can spread across the horizon, bringing gray, even light. Towering cumulonimbus clouds rise like mountains, carrying the potential for storms. Each type reflects the balance of air movement, temperature, and humidity in that part of the atmosphere. And though their forms vary, all of them share the same essence. They are collections of droplets, gathered together in suspension. For the droplets inside, the cloud is a shelter. Here, they can exist without immediately falling to the ground. They are held aloft by the movements of air, by the delicate interplay between upward currents and gravity. Inside this home, droplets may grow, colliding softly with others, merging into larger drops. Or they may evaporate back into vapor, contributing to the living cycle of the cloud itself. Nothing is static. Everything is moving, even if our eyes perceive calm. The thickness and color of a cloud reveal part of its nature. A thin cloud lets much sunlight pass through, appearing light and soft. A thicker cloud scatters more light, appearing darker from below. When a cloud grows heavy with droplets, its base may darken, signaling that rain is near. Yet even in its heaviest state, the cloud is still a floating congregation of droplets, patiently preparing the way for precipitation. Clouds also play a role in the comfort of life on Earth. They moderate temperature, shading the ground from intense sun and trapping warmth at night like a blanket. They are part of the planet's rhythm of cooling and warming, balancing extremes. When you feel relief under a cloud shade on a hot day, you are experiencing this gentle service. Clouds are not only homes for droplets. They are guardians of climate, caretakers of balance. If you imagine yourself moving gently inside a cloud, you would find not a solid wall, but a fine mist. Visibility would shrink, the droplets clinging to your skin and hair. The experience would be damp but light, like walking through breath itself. This helps explain why mountains often seem to wear a cap of cloud. The peaks are simply high enough to touch the level of condensation. Standing within the home where droplets live. From an energy perspective, clouds are also remarkable. As droplets form through condensation, they release latent heat into them. Air. This warmth fuels the rising of air, which in turn draws up more moisture, leading to further condensation. A cloud is, in this way, a gentle engine, circulating energy through the atmosphere, maintaining motion in a system that never stops. Beyond their physical nature, clouds have always carried meaning for people. They have been read as signs of weather to come, as symbols in art, as sources of inspiration for poets and thinkers. Their shapes and colors change constantly, reminding us of impermanence and flow. And within all those meanings lies the quiet truth. They are simply homes for droplets, patiently building the rain that nourishes the earth. Without clouds, rain could not exist. Vapor would remain invisible, scattered through the air. It is only when clouds form that droplets can gather in sufficient numbers to grow and eventually fall. The cloud is the essential step between hidden vapor and falling rain. It is the visible announcement that the water cycle is at work, that the atmosphere is preparing to give back what it has gathered. When you next look at a cloud, you might notice how soft it appears, how it drifts without effort. You might remember that inside it are countless droplets, each one held aloft in delicate balance. And you might realize that the cloud is not only a feature of the sky, but a necessary stage in the endless rhythm of water on Earth. Clouds remind us that even the heaviest rain begins with something light, suspended, and patient. They are the quiet homes of droplets, the waiting rooms of rain. Within their softness, the story of water continues, calm and unhurried, preparing always for the moment when droplets will be released back to the ground. When you imagine a raindrop, what picture comes to mind? For many people, the image is the familiar teardrop shape, narrow at the top and rounded at the bottom. This is the symbol we draw in pictures, the shape we place on weather forecasts, the way we describe raindrops in stories. And yet, real raindrops are not shaped like teardrops. In truth, they are round. Their roundness is one of the quiet wonders of physics, a natural outcome of the way water holds itself together. The reason droplets are round is surface tension. Water molecules attract each other. Each molecule is constantly reaching, pulling, and holding on to its neighbors. At the surface of a liquid, this attraction creates a kind of invisible skin. The molecules at the edge are drawn inward by those inside, creating a force that tries to minimize the surface area. Out of all possible shapes, the sphere has the smallest surface area for a given volume. And so, when water is left to its own balance, it becomes a sphere. You can see this principle in small ways around you. A bead of dew on grass in the early morning forms a near-perfect sphere. A drop of water on a waxed leaf sits rounded, resisting the pull of spreading out. On a tabletop, a droplet will hold itself together in a curved form until it evaporates. All of these examples reveal the same truth. Water prefers roundness. Inside a cloud, droplets begin as tiny spheres. At such a small size, surface tension completely dominates, and gravity has almost no effect. Each droplet is like a microscopic pearl suspended in the air, light and perfectly curved. Billions of these spheres together make up the body of a cloud. They drift and dance, constantly merging and separating, but their form remains round dot. As droplets grow larger and begin to fall, the story changes slightly. Gravity starts to compete with surface tension. Air pushes against the falling droplet, flattening it gently at the bottom. The larger the droplet becomes, the more noticeable this flattening is. Small raindrops remain almost perfectly round. Medium-sized drops take on a shape more like a hamburger bun, rounded on top and flatter beneath. Very large drops may even become unstable, breaking apart into smaller ones before they reach the ground. But even then, none take the shape of the sharp teardrop we often imagine. The reality is rounder, softer, calmer dot. The roundness of droplets is more than just a curiosity. It is also a lesson in efficiency. Nature often finds the simplest, most balanced form. By becoming spherical, droplets minimize energy, reduce strain, and hold together with stability. The same principle appears in many places: bubbles of soap, planets in space, even cells in the body. All tend toward the sphere, because the sphere is the form that balances forces with the least effort. Thinking of raindrops as round rather than pointed also changes how we experience them. The softness of their touch on skin, the way they gather. On windows, the way they ripple water surfaces, all are shaped by their roundness. When they fall, they do not cut or pierce, but land with a rounded gentleness, spreading outward rather than striking sharply. Even in a heavy storm, each drop is curved, not harsh, formed by balance rather than by force. There are small demonstrations that reveal this principle in simple, calming ways. If you let water drip slowly from a faucet, you will see each droplet hanging rounded before it falls. For a moment, surface tension holds it in place, a sphere stretching under the pull of gravity, then breaking free, falling still curved. The drop may flatten slightly as it descends, but its nature is always to remain round. You can also notice the roundness of water when it floats in a place without gravity. Astronauts in orbit, where there is no strong downward pull, see water forming into perfect spheres, drifting gently in the air. Freed from weight, surface tension alone shapes the liquid, and the result is flawless roundness. This is the same principle at work in every raindrop, though in our skies, gravity and air resistance soften the effect out. It is worth reflecting that the symbol of the teardrop persists, not because it is accurate, but because it is simple for drawing. Our hands find it easier to sketch a pointed shape than a perfect sphere. Over time, that symbol became part of culture, repeated in art, weather icons, and language. Yet the truth of raindrops is subtler. They are not pointed tears, but rounded, beads of water falling calmly from the clouds above. The roundness of droplets also influences how light interacts with them. Rainbows, for example, are formed when sunlight bends and reflects inside spherical raindrops. If raindrops were sharp or angular, the arcs of color would not appear in the same way. The softness and beauty of rainbows is made possible by the roundness of rain itself. In this sense, the shape of droplets is not only a fact of physics, but a source of natural wonder. There is comfort in knowing that something as simple as roundness can hold such meaning. It is a reminder that balance often lies in simplicity. A droplet could, in theory, take many shapes, but it always returns to the one that requires the least strain. Roundness is efficiency. Roundness is calm. Roundness is the form of least resistance, the shape that nature chooses when left to itself. The next time you feel raindrops on your skin, you might pause to remember their true form. They are not sharp points striking you, but rounded beads softened by surface tension, shaped by balance. You are being touched by small spheres of water, created high above, sustained by the gentle laws of physics. In that roundness lies the patience of nature, the quiet assurance that balance is always possible. Raindrops, in their round form, reveal that the world tends towards softness when it is allowed to find its own way. Even as they fall, even as they gather and scatter, their shape is calm, curved, complete. They are reminders that nature, in its quiet processes, chooses harmony over sharpness, balance over complexity. And so, the roundness of droplets is not only a detail of physics. It is a symbol of calm in motion, a gentle truth falling softly from the sky. When we see a cloud above us, full of droplets, it may seem natural to wonder, if clouds are made of water, why does that water not simply fall to the ground right away? Why does a cloud sometimes float for hours, drifting gently, before it releases? A single drop of rain? The answer is a calm one. Rain does not fall immediately because droplets begin too small, too light, too easily held aloft. They need time, growth, and balance before gravity can bring them down. A cloud is made of millions, even billions, of microscopic droplets. Each droplet is tiny, less than 1/100th of a millimeter across. At that scale, surface tension holds them together, and air resistance prevents them from falling. To the upward motion of air currents, they are almost weightless. Imagine a speck of dust caught in a soft breeze. It drifts, suspended, unable to sink. In the same way, the smallest droplets inside clouds are lifted and carried by the gentle currents of air. The atmosphere is not still. Within a cloud, air is constantly rising and moving. Warm air ascends, cooled air sinks, currents twist and circulate. These motions create an invisible support for droplets, keeping them suspended. Even as gravity pulls downward, the upward currents of air provide balance. As long as a droplet remains small, this balance holds. The droplet floats. The cloud remains a cloud. For droplets to fall, they must grow. Growth happens through two main paths. The first is condensation, where vapor continues to settle onto the surface of an existing droplet. Molecule by molecule, the droplet becomes larger. The second is collision and coalescence, where droplets bump into one another, merge, and combine. Each collision adds mass, and over time, a droplet may become big enough to resist the lifting currents. This process is gradual. Condensation builds slowly because a single molecule of vapor is unimaginably small. Billions are needed to make a droplet large enough to fall. Collisions also take time, depending on how dense the cloud is and how active the currents are. The entire system is unhurried. A cloud can hold its water for long stretches, carrying droplets that are always forming, merging, and sometimes evaporating. Again, it is helpful to remember that gravity does act on every droplet from the moment it forms. The pull is constant, but whether that pull results in falling depends on size. A droplet smaller than 20 micrometers can descend only a few millimeters per second. The upward motion of air in a cloud easily exceeds this, so the droplet is lifted back up, recycled into the flow. Only when a droplet grows beyond about 100 micrometers does gravity begin to dominate. At that point, the droplet sinks more steadily. When enough such droplets exist, the cloud begins to release raindrop in this way. Clouds are like patient nurseries, allowing droplets to mature before letting them go. The time between the birth of a droplet and its fall as rain may be minutes, or hours, depending on conditions. Some droplets may never fall at all. They may evaporate back into vapor before reaching the size needed to descend. What we eventually experience as rain is only a fraction of the droplets that formed. Many are created, recycled, and dissolved invisibly, without ever touching the ground. The delay of rain is also tied to balance in the atmosphere. Rising warm air keeps clouds alive. As long as the upward currents remain strong, droplets are carried aloft, kept from falling. When the air cools, when currents weaken, or when droplets grow too large to be lifted, the balance shifts. Gravity then takes the lead, and rain begins. In this sense, rain is not a sudden decision, but a shift in balance, a quiet tipping of scales. This patience has effects we can notice in daily life. A cloud may darken and thicken, signaling the droplets inside are growing larger. For a while, nothing falls. Then, gradually, the first drops reach the ground, often scattered, sparse, almost hesitant. As more droplets reach the critical size, the rain becomes steadier. A shower that feels sudden to us has in fact been preparing quietly for a long time. The delayed fall of droplets is also why rain can take so many forms. A thin cloud with limited growth may release only a fine drizzle, the droplets small enough to float slowly downward. A thicker, more turbulent cloud may allow droplets to grow larger, falling faster and producing heavy rain. The type of rain is shaped by how long droplets remain suspended before gravity wins. There is comfort in realizing that even rain is not rushed. The water cycle allows droplets to linger, to gather strength, before beginning their descent. What looks like stillness in the sky is, in truth, a period of preparation. Rain waits until the moment is right. Only when balance tips, only when droplets are ready, does the gift of falling water arrive. In this way, the delay between droplet formation and rainfall is not a flaw, but a design. It ensures that when rain does fall, it is meaningful. The droplets have grown large enough to reach the surface, to nourish plants, to fill streams, to touch our lives. If every tiny droplet fell immediately, most would evaporate before reaching the ground. The earth would receive little of the water it needs. By holding droplets until they are ready, clouds ensure that rain is effective, gentle, and sustaining. So the next time you look at a cloud and wonder why rain has not yet begun, you might remember this quiet story. Inside that cloud, droplets are forming, growing, colliding, sometimes dissolving, sometimes waiting. The delay is not emptiness, but process. It is the patience of nature, the rhythm of preparation. Rain is not fall immediately, because nature values balance over haste. Each drop waits for its right moment, suspended in the home of clouds, before beginning its calm journey to the earth below. When rain begins to fall, it does more than moisten the ground. It fills the world with sound. The rhythm of droplets meeting surfaces creates a natural music, one that has no composer and no beginning or end, yet feels endlessly familiar. The sounds of rain are among the gentlest in nature, and they are part of why rain is not only seen and felt, but also deeply heard. The sound of rain is born in the meeting of water and matter. Each droplet, though small, carries energy as it falls. When it lands, that energy is released as vibration. The surface touched, whether leaf, roof, soil, or water, shapes how the vibration travels. The result is a spectrum of tones: soft taps, resonant thuds, delicate patters, hushed murmurs. All together, they form a texture of sound that is rich yet calming. On a tin roof, raindrops make a crisp drumming, sharp yet rhythmic, filling space with a steady pulse. On broad leaves, they create a gentler patter, each impact softened by the flexible surface. On soil, the sound is muted, absorbed quickly into the ground. And on open water, rain becomes a chorus of tiny splashes, each drop creating ripples and bubbles that merge into a soft hiss. The diversity of surfaces turns rainfall into an orchestra of subtle instruments. The size of the droplet also matters. Small droplets falling lightly produce faint, high-pitched sounds like the brushing of fingers across fabric. Larger drops strike with more force, creating deeper, fuller tones. In a drizzle, the sound is scattered and delicate. In a shower, it is more insistent, filling the air with texture. In a downpour, the combined impacts create a steady roar. Yet even then, the sound remains continuous, without sharp edges. It envelops rather than startles. One of the most distinctive qualities of rain sound is its randomness within rhythm. No two droplets fall at exactly the same moment, yet the sheer number of impacts creates a sense of steady pattern. This blend of unpredictability and constancy is especially soothing to the brain. It is complex enough to hold gentle attention, but regular enough to feel safe. Psychologists sometimes describe this as pink noise, a balanced spectrum of sound frequencies that humans find calming. This may help explain why many people fall asleep more easily to the sound of rain. The ear receives a continuous flow of soft impacts, while the mind rests in the absence of sudden changes. There is no alarm, no sharp beginning or end. Instead, there is immersion. The world is filled with a blanket of sound that quiets thought and slows the rhythm of the body, like a natural lullaby created by water and air. Beyond comfort, rain sounds also carry information. To those who listen closely, the tone of rainfall reveals its character. A sparse pattern of taps may mean a light drizzle, a fuller chorus may indicate steady rain, and a deep, heavy roar may signal an approaching storm. Farmers, travelers, and those living close to the land have long read the sound of rain as a message. It is knowledge carried not by sight, but by ear. Rain sounds can also change over time within a single shower. At the beginning, the drops may be scattered, each impact distinct. As rain strengthens, the sound becomes more continuous, the gaps between impacts filled until the ear perceives a seamless wash of tone. When rain begins to fade, the sound thins again, returning to scattered notes like the final measures of a soft composition. In this way, a rainfall is like a piece of music that rises, sustains, and slowly dissolves. Another layer of rain sound lies in resonance. When drops fall into puddles, they create bubbles. As these bubbles form and burst, they release tiny bursts of vibration. Together, millions of bubbles add texture to the sound of rain on water. Oceanographers have even used underwater microphones to measure rainfall at sea, reading the pitch of bubbles to estimate drop size and intensity. The sound is not only aesthetic, it is scientific, carrying clues about the rain itself for humans. However, the deeper meaning of rain's sound is often emotional. To sit indoors on a rainy day and listen to drops on windows is to feel sheltered. The sound confirms the presence of weather outside while reminding you of the safety within. To lie beneath a roof and hear rain falling above is to rest in a cocoon of sound enclosed by rhythm. To walk through gentle rain and hear it strike leaves around you is to be wrapped in nature's own whisper. Cultures across the world have recognized this quality. In poems, in lullabies, in stories, rain is often described as soothing sound, a backdrop for thought and memory. Some languages have specific words for the murmur of rainfall, capturing what is universal, the comfort of hearing water descend. Musicians, too, have imitated the sound of rain in instruments, from delicate drumming to soft shakers, translating natural rhythm into human art. Modern technology continues this tradition. Many people now use recordings of rainfall as a tool for sleep or concentration. These recordings recreate the random, steady pattern that calms the nervous system. Though captured by microphones, they echo the ancient presence of rain as sound, carrying the same law that people have known for thousands of years. The sound of rain also connects us to memory. Hearing it may recall nights of childhood, moments of shelter, times of reflection. The sound is not only physical, but layered with associations. It can bring comfort, not just through its rhythm, but through the way it reminds us of times when we felt safe, calm, or close to the natural world. It is worth noticing that the sound of rain is always soft compared to its power. Rain can move mountains through erosion, feed rivers that shape continents, and sustain forests across the globe. Yet its sound is gentle, understated, almost shy. This contrast reminds us that strength need not be loud. Water, even in its most transformative form, speaks in whispers. So when you next hear rain, you might pause not only to feel its coolness or see its patterns, but also to listen. Each sound you hear is the story of a droplet meeting the world, releasing its energy as vibration. Together, those countless impacts create a soundscape that is both endlessly varied and endlessly calming. Rain speaks to us, not with words, but with rhythm. Its voice is patient, its music without haste. It reminds us that even in change, there can be gentleness. In every patter, in every hiss, in every soft drumming, the world is offering a calm song, written not in notes, but in drops. When rain begins to fall, it brings more than water. It also brings a scent earthy, fresh, grounding. Many people recognize this fragrance instantly, even if they do not know its name. It is the smell of rain on dry soil, the aroma that rises from the ground after a storm. Scientists call it petrichor, a word that comes from Greek, meaning the essence of stone. It is one of the most subtle, yet one of the most beloved gifts of rainfall. The smell of rain may feel like a mystery. because water itself is odorless. Pure droplets falling from the clouds have no scent. The fragrance comes from what happens. When the rain meets the earth, when droplets strike soil, plants, and rocks, and release compounds that have been resting quietly, the scent is not in the water, but in the conversation between water and ground. One of the main contributors to Petrichor is a family of natural oils produced by plants. During dry periods, plants release these oils into the soil and onto surfaces. The oils accumulate, waiting silently until rain returns. When raindrops strike, the oils are lifted into the air, carried on tiny bubbles, and dispersed as a fine mist. This release is what gives rain its earthy tone, a fragrance that feels both ancient and immediate. Another key player is a compound called geosmin. Geosmin is produced by soil-dwelling bacteria, especially a group known as actinobacteria. These microbes are part of the natural community of the earth, breaking down organic material, recycling nutrients, and sustaining the fertility of soil. In the process, they create geosmin, a molecule with a distinctly earthy scent. Humans are remarkably sensitive to it, able to detect it in concentrations as low as a few parts per trillion. When rain disturbs the soil, geosmin is carried upward into the air, and we breathe in the fragrance of microbial life. The interaction of these elements, plant oils, geosmin, and the action of raindrops creates the complex smell we call petrichor. It is not a single scent, but a blend of natural compounds mixed by rainfall into an aroma that is instantly recognizable. This is why the smell of rain is strongest after a long dry spell. The longer the soil waits, the more oils and compounds accumulate. When rain finally falls, the release is powerful, a sudden chorus after silence. The way this release happens is gentle, yet fascinating. When a raindrop hits the ground, it traps a tiny bubble of air. As the bubble rises and bursts, it launches microscopic particles into the atmosphere. These particles carry the plant oils and microbial compounds that create the scent. Billions of raindrops striking soil create billions of tiny bursts, filling the air with the fragrance of rain. For humans, the smell of rain has deep associations. It often brings a sense of nostalgia, a feeling of calm, a reminder of growth and renewal. Some scientists believe this response is evolutionary. Because rain has always been linked with fertile soil and the return of life, the scent may have become tied to survival. To smell petrichor is to sense that water has come, that crops will grow, that life will be sustained. Our bodies may be tuned to read the fragrance as reassurance. Petrichor also varies with place. Rain falling on a desert releases a sharper, dustier tone. Rain on a forest floor produces a deeper, richer scent, blended with the aroma of leaves and moss. Rain in cities may carry hints of stone, pavement, or even faint traces of pollution. Each landscape adds its own ingredients, so that the smell of rain is always familiar, yet always specific to the ground it touches. For many, the smell of rain is more than chemistry. It is memory. It recalls childhood days of storms, the opening of windows after heat, the coolness of soil after summer drought. It connects people to the land, to times of pause, to the rhythm of seasons. Because the scent is subtle and fleeting, it is especially tied to moments of presence. You notice it, breathe it in, and remember. In art and culture, petrichor has been described as the fragrance of renewal. Writers have used it as a metaphor for cleansing, for beginnings, for the gentle power of nature. It appears in poetry, in music, in reflections on the bond between humans and the earth. Though the word itself is modern, the experience is as old as rainfall itself. For as long as people have lived, they have breathed in the smell of rain and found it comforting. From a scientific perspective, petrichor is also important in understanding ecosystems. The presence of geosmin signals the health of soil microbes. The release of plant oils shows how vegetation adapts to dry and wet cycles. What humans experience as a fragrance is, in fact, a language of chemistry, carrying information about the state of the land. We interpret it emotionally, but its roots are biological and ecological. Yet, in the context of calm reflection, it is not necessary to analyze every detail. It is enough to know that the smell of rain is the earth speaking, softly reminding us of cycles far older than ourselves. Each breath of petrichor is a meeting with the ancient processes of soil, plant, and water. It is a quiet assurance that life continues, that balance returns, that the hidden world of microbes and roots is still alive. The next time you step outside after rainfall and inhale the fragrance, you might pause to notice how it makes you feel. Perhaps it stirs peace, perhaps memory, perhaps a gentle happiness. Whatever the response, it is evidence of connection to the ground, to the water cycle, to the unseen life that sustains the planet. Petrichor is not only a scent. It is an experience of belonging. It is rain reminding us that we are part of the earth, sharing the same cycles, breathing the same air, grounded in the same soil. In every fragrance that rises after rain, there is the presence of life's quiet persistence. When rain falls, it may seem like a simple event, droplets from the sky landing on the ground. Yet in truth, rain is one of the most important forces in sustaining life on Earth. Without rain, ecosystems would falter, soils would dry, rivers would shrink, and countless forms of life would struggle. Every shower, every drizzle, every downpour plays a role in renewing the balance of nature. Rain is the lifeblood of ecosystems, the quiet link that ties together land, plants, animals, and people. The most immediate role of rain is to nourish plants. Every leaf, every root, every blade of grass depends on water to grow. When rain falls, it soaks into the soil, reaching seeds, roots, and underground networks. Plants draw this moisture upward, using it to create food through photosynthesis. Without rainfall, plants cannot flourish, and without plants, ecosystems lose their foundation. Grasslands, forests, and wetlands all rely on the steady return of rain to remain alive, and green dot rain also replenishes rivers, lakes, and streams. The water that falls onto hillsides and mountains trickles downward, collecting into rivulets and channels. These join into larger streams, which feed rivers, which eventually return water to the seas. Along the way, they provide habitats for fish, amphibians, birds, and countless other creatures. When rivers swell with rainfall, they connect ecosystems. Across great distances, linking mountain slopes to valleys, forests to plains, and wetlands to oceans. Another role of rain is to shape soil itself. As droplets strike the ground, they loosen particles, carry nutrients downward, and recharge groundwater. In moderation, this process enriches the soil, ensuring that plants receive the minerals they need. In excess, heavy rainfall can cause erosion, carving gullies, shifting sediments, and reshaping landscapes. But even this movement becomes part of ecological balance, redistributing materials, renewing habitats, and creating new opportunities for growth. For animals, rain is both resource and signal. Many creatures drink directly from rainwater, lapping it from leaves, puddles, and streams. Some species time their breeding cycles to the arrival of rains, knowing that water will bring food and shelter. Insects hatch when puddles form. Frogs call loudly after storms, gathering in temporary pools to reproduce. Birds adjust their movements based on rainfall, migrating toward regions where water ensures abundance. In this way, rain is more than hydration. It is a cue for life's rhythms. Rain also sustains forests and jungles that act as the lungs of the planet. Tropical rainforests, for example, exist only because of constant rainfall. The trees of these regions release moisture back into the atmosphere through transpiration, creating their own clouds and drawing further rain. This cycle is self-sustaining, a living exchange between forest and sky. Without rainfall, these ecosystems would wither, and with them would go much of the biodiversity of Earth. Even dry regions depend on rain, though in rarer cycles. Deserts, where rain may come only once or twice a year, burst into life after a storm. Seeds that have lain dormant awaken, plants flower briefly, and insects and animals rush to take advantage of the fleeting water. For these ecosystems, rain is not constant, but its rare arrival is transformative, a moment of abundance in an otherwise harsh environment. The role of rain extends beneath the surface as well. As water seeps through soil and rock, it replenishes. Aquifers' hidden stores of groundwater that feed springs and wells. These underground reserves sustain ecosystems during dry times, releasing water slowly, long after the rain has stopped. Without replenishment from rainfall, aquifers would shrink, leaving landscapes vulnerable to drought. Rain also cleanses the atmosphere. As droplets fall, they capture dust, pollen, and tiny particles, carrying them to the ground. This washing of the air clears the sky, improves visibility, and reduces the load of pollutants. For ecosystems, this cleansing is subtle but important, maintaining healthier air and surfaces for plants and animals alike. In coastal regions, rainfall helps balance the boundary between land and sea. By feeding rivers that carry nutrients into estuaries, rain supports the rich ecosystems of tidal marshes, mangroves, and coastal wetlands. These zones are nurseries for fish, crabs, and birds, sustained by the flow of fresh water meeting salt. Without the steady input of rainfall, these ecosystems would collapse, and the chain of life connected to them would weaken. Rain also has an emotional role in ecosystems of human life. Farmers wait for it to nourish crops. Communities build rituals around it, celebrating its arrival, fearing its absence. Civilizations have flourished where rainfall was steady and collapsed where it failed. The history of human culture is bound to the rhythms of rain, just as much as forests or rivers are. The beauty of rain's role in ecosystems is its universality. It sustains lush jungles, quiet grasslands, frozen tundras, and arid deserts. Each landscape interacts with rainfall in its own way, but all depend on it. The water that falls from the sky becomes streams, forests, food, shelter, and life. It becomes the foundation for cycles that continue endlessly. Linking clouds above to roots below. It is calming to reflect that something as gentle as a raindrop can sustain so much. No single drop carries the whole burden, yet together, drops weave the fabric of ecosystems. They fall softly, steadily, repeatedly, maintaining balance not through force, but through persistence. Over time, their role becomes undeniable. Rain is not spectacular in each moment, but it is essential in every moment. So, when you watch rainfall, you might remember that you are witnessing a process that sustains entire worlds of life. Each drop nourishes soil, feeds rivers, awakens seeds, signals animals, and connects sky to earth. Rain is not just water, it is the quiet heartbeat of ecosystems, a gift that repeats endlessly, sustaining balance across the living planet. Rain is only one moment in a much larger journey. To understand rain fully, we must see it not as an isolated event, but as part of the hydrological cycle, the endless movement of water through Earth's systems. This cycle has no beginning and no end. It is a rhythm as old as the planet itself, repeating quietly, sustaining every form of life. The hydrological cycle begins with evaporation. Under the warmth of the sun, water from oceans, lakes, and rivers gains energy. Molecules move faster, and some escape into the air as vapor. This process is invisible, yet it is constant, lifting vast amounts of water into the atmosphere every day. Evaporation is the Earth's gentle exhalation, releasing moisture upward into the sky. Alongside evaporation is transpiration, the release of water vapor from plants. Through tiny pores in their leaves, plants breathe out moisture, adding to the atmosphere's reservoir. In forests and grasslands, transpiration is immense. A single tree can release hundreds of liters of water in a day. Together, millions of plants shape the humidity of regions, creating clouds and influencing local rainfall. In this way, vegetation is not just nourished by the cycle it participates in it, actively shaping the return of rain. Once vapor is in the atmosphere, it rises with air currents, cools, and condenses into droplets, forming clouds. This is the stage where the invisible becomes visible. The sky gathers the moisture released from oceans and forests, holding it aloft until the balance tips. As droplets grow heavy, they fall as precipitation, rain, snow, hail, or sleet, depending on conditions. Precipitation is the Earth's inhalation, returning water to the surface. When rain reaches the ground, its journey takes many paths. Some water runs off across the surface, flowing into streams and rivers, feeding lakes and seas. Some soaks into soil, nourishing plants and recharging groundwater. Some infiltrates deep into rock layers, becoming part of aquifers' hidden reserves that sustain wells, springs, and ecosystems during dry times. Each path is essential. Each path ensures that water continues to circulate, touching every part of the planet. Eventually, all water returns to the oceans, completing the cycle. But the return is never final. Oceans are the great reservoir, yet they constantly release vapor back into the air, starting the process again. The cycle is endless, continuous, without pause. It connects every drop of rain to every river, every cloud to every ocean, every life form to the whole system of the Earth. The scale of the hydrological cycle is vast. It moves trillions of liters of water every day, yet it does so quietly, without effort. It is both immense and intimate. The water in your glass, the rain on your window, the snow on a mountain peak, all are part of the same cycle. The molecules are ancient, reused endlessly, circulating for billions of years. Some of the water you drink may once have been part of glaciers, part of rivers in distant lands, even part of oceans long vanished. The cycle also balances climates. By moving water across the globe, it redistributes heat. Evaporation absorbs warmth, cooling surfaces. Condensation releases warmth, fueling air currents. Rainfall moderates temperature, refreshing landscapes. In this way, the cycle is not only about water, but also about energy. It is the quiet engine that regulates the Earth's climate, ensuring stability across time. The hydrological cycle varies in rhythm from place to place. In the tropics, where heat and vegetation are abundant, the cycle is rapid and intense. Rain falls often, and moisture returns quickly to the air. In deserts, the cycle slows, with rare rainfall and long waits for renewal. In polar regions, much water is locked as ice, and the cycle stretches across centuries as glaciers melt and refreeze. Yet everywhere, the rhythm continues. No region is outside the cycle. For humans, the hydrological cycle is both background and necessity. It fills rivers that provide drinking water. It irrigates crops, sustains livestock, and powers industry. It shapes weather, influences seasons, and defines where civilizations can thrive. Entire cultures have risen in places where the cycle provided steady rain, and entire migrations have occurred where the cycle faltered, though we rarely notice. This endless rhythm is woven into every aspect of human history. The cycle is also resilient. Though it shifts with climate and geography, it never stops. Even in droughts, evaporation continues. Even in floods, water eventually returns to balance. Over millions of years, the cycle has endured ice ages, volcanic eruptions, and shifting continents. Through all change, the water has kept moving, rising, condensing, falling, and flowing. To reflect on the hydrological cycle is to see water as more than substance. It is motion, connection, renewal. It is the thread that links clouds, rivers, forests, oceans, and living beings into one great pattern. Every droplet is part of that story. Every raindrop on your hand has traveled this path countless times, part of a cycle that existed long before us and will continue long after God. So, when you watch rain falling, you are not only seeing weather, you are witnessing a moment in the hydrological cycle, a stage in the endless rhythm of water. That drop may have risen from the sea, drifted across continents, and now returned to nourish soil. Soon, it will move on again, carried by rivers, or absorbed by plants, eventually lifted once more into the sky. The cycle is patient, unbroken, eternal. Rain is not always the same. Though we use one word to describe it, rain arrives in many forms. Sometimes it is light, almost imperceptible, a soft drizzle that barely weights the skin. Sometimes it is steady, filling rivers and soaking fields. And sometimes it is intense, falling in sheets that blur the horizon. Each type of rain has its own rhythm, its own texture, its own quiet meaning. One of the gentlest forms is drizzle. Drizzle consists of very small droplets, so light that they drift downward more than they fall. They seem to float in the air, settling on surfaces gradually, often without sound. Walking through drizzle feels less like being rained on and more like stepping into a fine mist. This type of rain does not rush. It nourishes plants, moistens soil, and refreshes air in the lightest way possible, patient and soft. Showers are different. A shower begins suddenly, bringing a burst of rain that lasts minutes or hours before fading again. The word shower suggests washing, and indeed these rains cleanse the air, cool the ground, and pass on. Showers are often linked to local clouds that grow quickly in rising air and then release their water. They can be playful, unpredictable, one moment clear, the next moment filled with drops, then clear again. Their rhythm is that of a passing mood, brief yet refreshing. When droplets grow larger and fall more quickly, rain becomes heavy. A steady downpour fills the air with sound and motion, the ground with puddles and streams. Large raindrops fall with force, and yet they are still curved, still soft in shape, falling not to harm, but to nourish. Downpours bring water in abundance, replenishing reservoirs and rivers, feeding ecosystems that depend on volume as much as frequency. Though they may feel overwhelming in the moment, their role is one of generosity. In tropical regions, monsoon rains arrive as a season rather than an event. For months, Moist air flows steadily from oceans onto land, releasing rain day after day. These rains are not just weather. They are the backbone of agriculture, culture, and survival. Fields fill, rivers swell, forests thrive. People plan there. Lives around the arrival of the monsoon, waiting for its return as assurance of renewal. Though intense, monsoons are also rhythmic, part of a larger cycle that communities have trusted for generations. There are also rare but fascinating forms of rain. Freezing rain, for example, falls as liquid but turns to ice the moment it touches cold surfaces. Roads, trees, and wires become coated in a clear glaze. Though this can be dangerous, the phenomenon itself is delicate a balance between temperatures, above and below freezing, creating a thin layer of crystal across the world. It is a reminder that rain takes many shapes, depending on the air it travels through. Sleet and snow are further variations. Though they are technically frozen forms of precipitation, they belong to the same cycle. Snowflakes form when vapor crystallizes directly into ice, creating intricate patterns. Sleet occurs when raindrops refreeze on their way down, becoming tiny pellets of ice. Each is another expression of water's patience, shaped by temperature and altitude. Even within liquid rain, texture varies endlessly. Gentle summer showers feel different from winter rains. Warm rain can fall softly, almost like a caress, while cold rain brings a sharper sensation, bracing and clear. Rain falling through clean mountain air carries a different freshness from rain in humid valleys. Each experience is personal, shaped by context, yet always tied to the same process of condensation. Growth and release dot the sound of each type. Of rain also differs. Drizzle barely registers, whispering on leaves. Showers create scattered patterns, playful and irregular. Downpours create a steady roar, enveloping everything in a wash of noise. Monsoon rains create a constant background, a deep pulse that seems endless. Each sound reflects the size, speed, and density of droplets, turning physics into music. For ecosystems, these differences matter. Drizzle nourishes mosses, lichens, and delicate plants that need gentle hydration. Heavy rains feed rivers and fill aquifers. Seasonal monsoons sustain entire agricultural systems. Freezing rain challenges forests, but also redistributes nutrients when ice breaks branches and clears old growth. Each type of rain has its place in the larger balance. None wasted, all essential. Humans, too, experience these forms differently. A light drizzle may invite a reflective walk. A sudden shower may call for shelter and pause. A heavy storm may remind us of nature's power, while a monsoon may anchor cultural rituals of gratitude. Rain in its many forms is woven into memory, language, and daily life, shaping how we live with the sky dot. It is calming to realize that rain does not need to be one thing. It adapts to conditions, taking whatever form is natural, always serving the same purpose of returning water to the earth. Whether mist or torrent, each type is part of the same rhythm, the same endless cycle. By noticing these differences, we see more of rain's character, more of its quiet versatility. So, when you next notice rain, you might pause to ask, is it drizzle, shower, downpour, or something rare? Each form carries its own softness, its own meaning. Each drop, no matter how it falls, belongs to the same cycle, the same gift of water. Rain is not only one voice, it is many voices, speaking in tones of mist, rhythm, abundance, and renewal. When raindrops reach the ground, they bring not only water, but also sensation. Sometimes the rain feels almost warm against the skin, a soft comfort, as if the sky itself were gentle. At other times, it feels cold, bracing, a reminder of higher altitudes and cooler air. The difference is not random. The warmth or coolness of rain is shaped by the journey each droplet takes as it falls from the clouds. Every raindrop begins high above, often thousands of meters in the air. There, the temperature may be very different from the ground. In some clouds, droplets form in chilly air, close to freezing. In others, especially in summer, they form in warmer, humid layers. As droplets descend, they pass through different layers of atmosphere, each with its own temperature. The droplet carries this history with it, cooling or warming as it falls, until it meets the skin. When rain feels warm, it usually means the air from cloud to ground is mild. In tropical or summer storms, the atmosphere can be warm all the way. Down. Droplets form in clouds that themselves are not far below freezing, or they melt quickly from ice crystals into liquid in layers of warm air. By the time they fall to the ground, they have had no chance to chill. Touching them feels like touching the air itself, soft, moist, and warm. When rain feels cold, the story is different. Often, droplets begin as ice crystals and very high, cold clouds. As they fall, they melt, but the air below remains cool enough that the drops never warm much. By the time they land, they carry the chill of the upper atmosphere. Cold rain is especially common in early spring or late autumn, when the surface is warming, but the higher air still remembers winter. It is also felt when winds bring cold layers downward, allowing raindrops to carry that coolness to the ground. Wind adds another influence. A cool breeze around rainfall can enhance the sensation of cold, carrying heat away from the skin more quickly. Conversely, when rain falls in still, humid air, it feels warmer because evaporation from the skin is slowed and heat is not removed as efficiently. The combination of droplet temperature and surrounding air shapes the experience of each rainfall. There is also a psychological element. Warm rain often feels pleasant, associated with summer showers, gentle storms, and childhood play. Cold rain, by contrast, can feel harsher, linked with gray skies, shivers, and the instinct to seek shelter. Yet both carry the same essence: water falling, nourishing, connecting sky and ground. The difference is only in how the atmosphere has shaped the droplet's journey. From a scientific view, the temperature of raindrops rarely differs greatly from the surrounding air. A droplet falling from cloud to ground adjusts quickly to its environment. If the air is warm, the drop warms. If the air is cold, it cools. What we feel on our skin is not just the drop's inherent temperature, but the combined effect of the drop and the air through which it falls. Freezing rain is an extreme case of this balance. Here, droplets fall through a layer of warm air and melt, becoming liquid, but then pass through colder air just above the ground. They remain liquid until they strike a surface, then freeze instantly. The result is rain that feels liquid but turns solid in an instant. A striking reminder of how layers of temperature shape every drop. Warm rain can also carry its own unique fragrance and mood. In tropical climates, showers may arrive suddenly, with drops that feel almost body temperature. The sensation is not of being chilled, but of being embraced by the atmosphere itself. The sound of warm rain is different, too softer, because droplets strike without sharpness, cushioned by humid. Air. Cold rain, on the other hand, sharpens awareness. Its drops strike with clarity, cooling skin and breath. It is the rain of mountain valleys, of early mornings, of seasons changing. Though less comforting, it is invigorating, reminding us of the bond between sky and earth in its raw form. Cold rain cleanses landscapes, clarifies air, and prepares ecosystems for transition. Both warm and cold rain are necessary for balance. Warm rains feed tropical forests, driving lush cycles of growth. Cold rains sustain temperate and northern ecosystems, refreshing soil and rivers during cooler months. Each form shapes the character of regions, guiding plants and animals, influencing culture and memory. For humans, the memory of rain's temperature is often tied to feeling. Warm rain recalls summer freedom, walking without worry, the joy of play. Cold rain recalls endurance, the need for shelter, the taste of fresh air on a brisk day. Each sensation connects body to sky in a different way, reminding us that weather is not just seen, but experienced through touch. It is calming too. Know that raindrops do not fall at random, but always carry the story of the air they have passed through. Each drop that touches you has traveled a path of warmth or coolness, a journey that ends in a brief moment on your skin. In that moment, you feel the atmosphere itself, the layers above, the winds around, the quiet processes that connect cloud to earth. So, when rain feels warm, you might imagine the gentle path it has taken, falling through mild air, carrying softness from sky to ground. And when rain feels cold, you might remember that it has journeyed through chill heights, bringing with it a whisper of the upper atmosphere. Both are natural, both are meaningful, both are part of the endless rhythm of water on earth. Rain is not only a physical event, it is also deeply woven into the human experience. From the earliest days of humanity, people have lived with rain as both blessing and challenge. It nourished crops, but it also interrupted journeys. It inspired songs, but it also shaped shelter. To this day, rain is more than droplets from the sky. It is part of how we feel, remember, and live. One of the most direct experiences of rain is emotional. Many people find comfort in listening to rainfall, whether on rooftops, leaves, or windows. The rhythm is calming, steady, without sudden changes. It quiets thought, slows breath, and brings a sense of security. For others, rain can feel melancholy, a soft backdrop to reflection or solitude. Both responses are natural, for rain has always accompanied human moods, echoing states of mind with its rhythm. Rain is also tied to memory. The smell of wet soil, the sound of drops at night, the sight of puddles forming on familiar streets, all can trigger recollections of childhood, travel, or quiet pauses. Because rain engages multiple senses at once, sight, sound, touch, smell, it imprints itself deeply. To feel rain is often to remember, to connect present moments with the long rhythm of personal history. Across cultures, rain has been honored and interpreted in countless ways. In some traditions, it is seen as a blessing from the heavens, bringing fertility and renewal. In others, it is a test of endurance, linked with storms and challenge. Farmers in every land have prayed for rain, celebrated its return, and feared its absence. Rituals, dances, and festivals around rain are ancient, reflecting how central rainfall has always been to survival. Art and literature have long drawn on rain as symbol. Poets describe it as cleansing, as sorrow, as rebirth. Painters capture its soft distortions of light, turning landscapes into blurred reflections. Musicians echo its rhythm in percussion and melody, creating songs that resemble the random, steady fall of drops. In every form, rain becomes a language through which humans express feeling and imagination. In daily life, rain shapes human rhythms. It determines when to sow fields, when to harvest, when to travel, when to rest. Entire calendars in agricultural societies were built around rainy seasons and dry seasons. Even today, in modern cities, Rain influences how we dress, how we move, how we gather. Umbrellas, coats, and shelter are all reminders that human routines remain connected to weather. Rain is also part of human shelter. The need to protect against wetness shaped the design of homes, roofs, clothing, and tools. The sound of rain on rooftops became not just background but proof of safety indoors. To hear rain while staying dry has always brought comfort, the assurance that shelter is working, that one is safe within walls. There is also a playful side to rain in human experience. Children splash in puddles, dance in showers, lift faces to the sky. Warm rains especially invite freedom because they do not chill but refresh. Even adults may recall times of walking without concern, letting rain soak clothes, enjoying the simplicity of water falling without restraint. Such moments remind us that rain is not only utility, but joy. In times of scarcity, rain carries deeper meaning. Droughts have shaped migrations, economies, even histories of nations. The arrival of long-awaited rain can feel like salvation, greeted with celebration. Stories of rain-breaking drought appear in sacred texts, myths, and oral traditions. In this sense, rain is not just weather, but divine presence, symbolizing hope and renewal after hardship. For individuals, rain can mark transitions. A sudden storm may accompany a moment of reflection. A quiet drizzle may frame a time of grief. A rainbow after rain may symbolize new beginnings. Because rain is both common and variable, it easily takes on personal meaning. Each person, in some way, has their own relationship with rain, built from encounters over a lifetime. Rain also brings people together. Families gather indoors, sharing time as showers pass. Communities adjust schedules, wait for skies to clear, or celebrate festivals when rains arrive. In rural areas, neighbors may help one another after storms, reinforcing bonds. Even in cities, the shared experience of walking through rain umbrellas lifted, coats drawn close creates a subtle sense of connection. It is important to notice that rain is not experienced the same everywhere. In tropical climates, rain is abundant and often warm, shaping cultures of rhythm and expectation. In temperate zones, rain is spread across seasons, a steady companion to changing weather. In deserts, rain is rare and revered, its arrival a very transformative event. Human experience of rain is shaped by place, but in every place, it carries meaning. The role of rain in human creativity also extends into modern times. Films and stories use rain as atmosphere, symbolizing turning points or emotional depth. Technology has even recreated the sound of rain in recordings for relaxation and sleep. People still turn to rain as a source of calm, even when far from storms. Its rhythm has become universal comfort, available anywhere through sound and memory. Reflecting on the human experience of rain shows us that water falling from the sky is never just water. It is feeling, memory, rhythm, culture. It is survival and art, shelter and play. It connects people across time and space, from ancient rituals to quiet modern evenings. Rain is both ordinary and extraordinary, part of the most intimate moments of life and the broadest movements of history. So, when rain next falls, you might notice not only its physical touch, but also its meaning for you. Perhaps it recalls a childhood walk, or a story you once read, or a ritual you have seen. Perhaps it brings comfort, or reflection, or joy. Whatever it brings, it is evidence that rain is more than droplets. It is a companion in human life, a soft presence that has always been with us. When we think of rain, we often imagine it as local, a shower passing over fields. A storm washing city streets, a drizzle softening the air. Yet rain is more than a local event. It is part of the planet's system of balance, regulating temperature, energy, and circulation. Rainfall is not only nourishment for soil. It is also one of the Earth's ways of keeping climate stable, moderating extremes, and sustaining life across generations. One of the most direct roles of rain in climate balance is cooling. When rain falls, it absorbs heat from the surfaces it touches. Warm pavements, dry soils, and overheated plants are cooled as droplets spread, evaporate, and carry heat away. This cooling is part of a larger pattern. Evaporation at the surface removes energy, condensation in clouds releases it, and rainfall redistributes it. In this way, the hydrological cycle becomes a conveyor of heat, carrying warmth from one place to another and preventing extremes from lasting too long. Rain also shapes humidity, the moisture content of the air. After rainfall, the atmosphere near the ground becomes saturated with water vapor, altering how heat is stored and released. Humid air holds warmth differently than dry air, slowing the loss of heat at night. This balance softens temperature swings, protecting ecosystems and human life from extremes. In regions where rain is frequent, climates are often more stable, buffered from rapid shifts. Another way rain balances climate is through circulation. The heat absorbed by water during evaporation is released back into the air when vapor condenses into droplets. This release of latent heat powers rising currents, which in turn drive winds and global circulation patterns. Rainfall is the visible outcome of this process, but behind it lies the movement of air masses that shape weather and distribute energy around the globe. Without this exchange, climates would fragment and large regions would swing between unbearable heat and deep cold. Rain also regulates the carbon cycle, indirectly stabilizing climate over long timescales. When rain falls on forests and grasslands, it sustains plants that absorb carbon dioxide. When it flows through soil, it carries dissolved minerals that eventually lock away carbon in rocks and oceans. Over millions of years, rainfall has been part of the processes that keep greenhouse gases in check, balancing the composition of the atmosphere. On shorter timescales, rainfall influences local climates. Tropical forests exist because of daily rain, and in turn, they create their own weather, recycling moisture through transpiration. Deserts exist partly because rainfall is absent, leaving heat unmoderated. Mountain climates are shaped by rain shadows, where one side of a range is cooled and green, while the other remains dry and hot. In each case, rainfall patterns dictate not just ecosystems, but the climate character of entire regions. Rain also cleanses the atmosphere. As droplets fall, they collect dust, pollen, and pollutants, carrying them down to the surface. This washing of the air improves clarity, reduces greenhouse effects of particles, and maintains the balance of radiation reaching the ground. After a rainfall, the sky often appears clearer and brighter, not only to our eyes, but in measurable ways that influence temperature and light. For oceans, rainfall is a key regulator of salinity. Freshwater input from rain balances evaporation in tropical seas. This balance affects density, which in turn drives ocean currents that distribute heat around the planet. Without rainfall, salinity would rise unchecked in some regions, altering currents and destabilizing global climate systems. Thus, the fall of rain into oceans far from shore is as important as the fall of rain on fields. Human cultures, too, experience the balancing role of rain. Societies have long noticed that rainfall cools heat waves, ends periods of dryness, and renews growth. Seasonal rains anchor calendars and traditions, marking shifts in climate that people depend on. Even in modern times, rainfall patterns influence agriculture, water supplies, and energy systems. Where rainfall is stable, societies flourish. Where it falters, people face drought, migration, and challenge. The balance rain provides is not always gentle in the short term. Heavy rains can flood, disrupt, and reshape landscapes. Yet even these extremes are part of long cycles, redistributing nutrients, refreshing aquifers, and maintaining large-scale equilibrium. What may feel destructive in a moment often serves renewal in the longer view, ensuring that systems do not stagnate. It is calming to realize that every raindrop contributes to climate balance. No single drop changes the world, but together they form patterns that regulate the planet's heartbeat. Rain falls, cools, nourishes, and cleanses, not as an isolated act, but as part of a global mechanism. Without rainfall, climates would drift into extremes. With it, the Earth remains steady enough for life to thrive. So, when you next notice rain, you might see it not only as local weather, but as a thread in the fabric of planetary balance. The drop on your skin, the shower on the ground, the storm. Across a region all are part of Earth's quiet effort to moderate, to stabilize, to continue. Rain is more than water. It is the Earth keeping itself in balance, one drop at a time. When we stand in the present moment and watch rain fall, it feels immediate. A current event touching our skin, cooling the air, softening the ground. Yet rain also belongs to a much larger story, one that stretches far beyond our lifetimes. To understand rain fully, we must see it not only as weather, but as time itself, an ancient, repeating rhythm that has shaped Earth for billions of years and will continue long after us. The story of rain begins with the early Earth, billions of years ago. As the young planet cooled, water vapor condensed and fell in rains that lasted for centuries. These ancient rains filled the first oceans, carving valleys, softening stone, creating the conditions in which life could begin. The very seas that cradle life today are the legacy of those primordial rains. Without them, Earth would be a dry, barren world, unfit for plants, animals, or people. Through geological time, rain has continued its patient work. Drop by drop, it has worn down mountains, transported sediments, and shaped landscapes. The grand canyon, river valleys, and fertile plains all bear the marks of rainfall's persistence. What seems solid in stone is, over long time, softened and moved by water. Rain is slow, but across centuries and millennia, it reshapes the face of the planet. Rain has also been constant through changes of climate. During ice ages, when glaciers covered continents, rain still fell, sometimes as snow, sometimes as sleet. Always part of the cycle. During warm periods, when forests stretched wide and oceans rose, rains were abundant, sustaining lush growth. No matter how climates shifted, rain remained. It adapted in form, but its rhythm never stopped. This continuity has given stability to life, allowing species to adapt and evolve across eras. For ecosystems, the perspective of rain over time is essential. Forests have risen and fallen with rainfall. Grasslands have expanded and contracted. As precipitation patterns shifted, deserts have blossomed briefly after rare rains and returned to waiting. Through all of this, rain has been the quiet architect, deciding where life thrives and where it withdraws. Every habitat on Earth is, in part, a reflection of rainfall patterns sustained over centuries. Human history, too, is marked by rain. Civilizations have flourished where rains were steady and reliable, such as along the Nile, the Tigris and Euphrates, the Indus and the Yangtze. Where rains failed or shifted, societies faced hardship, migration, or decline. Entire cultures developed rituals, calendars, and myths around rainfall, treating it not only as water, but as time itself, an event to be expected, awaited, remembered. Seasonal rains marked years as surely as calendars did. Over individual lifetimes, rain becomes a thread that ties moments together. A person may remember the first rains of childhood, the storms of adolescence, the quiet showers of later years. Each rainfall feels new, yet each is also part of the same endless cycle. The rain that falls today is not different in essence from the rain that fell on ancient forests or prehistoric seas. It is the same water, recycled endlessly, connecting generations through shared experience. Even in the present, rain teaches patience through time. A single storm may seem sudden, but its preparation takes hours or days in the forming of clouds, in the gathering of vapor, in the slow growth of droplets. In the same way, the work of rain across centuries is unhurried. Erosion, soil renewal, the carving of rivers, these are processes that span lifetimes. Rain reminds us that change can be both gentle and profound, both invisible in the moment and undeniable in the long view. Looking ahead, rain will remain part of Earth's story. Climate change may alter where and when it falls, intensifying storms in some places and lengthening droughts in others. Yet the cycle of evaporation, condensation, and precipitation will not stop. Rain will continue to fall, sustaining life in new forms, shaping landscapes in new ways. Long after individual lives and even civilizations pass, rain will still be present, repeating its quiet rhythm. Rain also offers perspective on our place in time. When we feel drops on our skin, we are touched by water that may have once fallen. On ancient seas, flowed through rivers long vanished, or nourished forests now fossilized. The molecules in a single raindrop may have cycled through countless lives, countless landscapes, countless ages. To experience rain is to share in this continuity, to participate in a cycle older than humanity itself. There is comfort in knowing that rain is timeless. It links past to present, present to future, with no break in its rhythm. It is the same today as it was for early humans, for prehistoric animals, for ancient plants, and it will be the same tomorrow, long after we are gone. In this way, rain is a reminder of endurance, of cycles that outlast individuals, cultures, and even eras. So, when you watch rainfall, you might imagine the vast timescales it connects. The droplet on your hand may be part of water that once filled glaciers, that once nourished dinosaurs, that once shaped mountains. Soon it will return to the air, rise again, and fall again. Rain is not only weather, it is time itself, written in water, repeating endlessly, quietly, patiently. This has been the Sleepy Brain Dose. You've journeyed through the quiet story of rain, the droplets, the clouds, the timeless rhythm of water. Now let the calm stay with you, like a soft echo of falling drops. Close your eyes, allow rest to come, and drift gently into sleep. Good night.